I can say that robot can do hazardous work where human cannot work, like where very less oxygen is there, or let's say there are toxic materials are surrounding, or temperature is more. So in such hazardous or difficult for human environments, that robot can work, and it also performs the task like repeatedly. So if the robot is doing that thing, he will not get fatigue, or he will not wait for the rest. Like he will not have a lunch time and all the things. He will not have a holiday. Once it is breakdown, we have to make it like service it by robot. And also for faster production rate, as I said earlier, that robotics, the like robotic arm is this one is programmed on, so it will perform this task very fastly. While on the other hand, human will like grab one thing, he will think about something else. There will be some another ideas going on in his mind. So there will be like he will be lazy after like 2 3 hours, but robot will not get lazy, and he will do it task with greater accuracy, so that we can achieve the faster production rate. Now there are some cons as well for this. So for operating this robot, operating means for programming it for the first time, we need a skilled manpower. So the ones which are skilled in programming, we need them also for a servicing, or let's say if anything happens with the robotic arm, then we have to like repair them. So for that also we have to use some skilled manpower. And because of this robotics, unemployability is also increasing, because they are working very faster and very accurate than human beings. That's why there are chances of unemployability. Morally this is not good, but for from the point of view like production or profit, robots are good. So now this is the particular robot which I designed for that competition, that FTC 2020. So for this I got that award. So here we have different things like this red and blue color. You can see red and black one. So those are 3D printed parts. As you can see on the right side, there is one gripper is there, and it have one jaw. This is a gripper and jaw. It operated by a servo motor. Okay, so as this is a linkage, mechanical linkage, and it is designed for doing the particular task, we are going to see that task in a short time. So this I can say that this is also a robot. So yeah, so let's see that thing. Yeah, so can you see the screen here, video? Hello.
It is loading, sir. Yes, sir. It's loading.
Yeah. Okay. Okay, so now for the this was like for 2 minutes and 30 seconds. This task was, so first 30 seconds was to do it automatically. That is the autonomous period. Now the robot is working. This particular one, the on the bottom side, you can see that robot is working with the help of some sensors. Okay, so very first it was here. So once that time is started, because with the help of sensor, it senses where that blue portion or blue platform is placed, and that it comes in front of it. And after that, seeing at it, it stop, and it placed that particular block into that particular things. And again, with the help of some another arm, it grab that platform, and it brings back like this. So this is totally a autonomous period. No human intervention was there, and now the robot will park at the particular thing like below the bridge. So that also done by using some sensors. Okay, now moving towards the last part. So see now, this is I was talking about the task which is that should be performed by the robots. So as you can see that stacking is done. That is a particular task assigned for that robot, and he's doing it. Yes. Hello. Hello.
Sir, please proceed. I think someone just joined with the microphone on.
Okay. Yeah. Should I continue?
Yes, sir, please.
Yeah. So that robot is performing that task. So yeah, as you can see, it is having different linkages. Earlier, the robot is very smaller one, like this one. It is having very short height, and now you can see how it is going moving up. So because it is having some linkages, so those are mechanically designed linkages. Yeah, this was the final round which we won. Yeah. So the intention behind showing this was to like show you how that robot is working and how you have to design the parts for that, like for performing particular task. So here everything is important. Like first thing, need. The need was to grab the block and to put it on the top, like making a skyscraper like thing. So for that, this particular robot was designed by using CAD and 3D printed, and now it is programmed. So unless and until you program your robot good, it will not perform anything. Unless, let's say, it is very good, mechanically well designed robot, it have very good motors and everything is very good, but programming is not done correctly, it will not perform any task. Okay, so for making that moving parts, we need different mechanical linkages, we need joints, actuators. In actuators, there are few, you can use electric motors or you can use hydraulics or pneumatics for that. Then brain of your robot, that is controller or processor, you can say that. And lastly, you need a power for operating things like these joints and this thing. Now for this, I can say human body is the best example for this one, because our body has different linkages. Let's say I have a forearm, then biceps and everything is there. Then I have joints, like shoulder joint, it is moving everywhere. Then we have fingers like hinge joints. So there are different joints present for moving differently and performing different tasks. So yeah, and we also need a processor. That our processor is nothing but our brain, and the food we eat, it gets converted into the power. So yeah, you can relate human body to the robot, but as we have feelings, we can say that we are a human being, and the robots, or which are mechanical things, they don't have a feeling. That is the cons of the robot. They can't think emotionally. So that is the con, or you can say it is also pro for the robots. Yeah, now these robots we can use for automation, like repeated tasks. Like I showed you in that video, there was some task provided to that robot, that he has to go, then pick the yellow block and go to that particular blue platform and stack it one above another. So that was the task. So we can do that task by human hands, right? So we can always go, we can pick the things and we can come. Now imagine that thing is happening on the Mars. So can we go on the Mars? No, because there is no, or there is very less oxygen which is not adequate for our life, or there are some hazardous toxins also in the air. So yeah, there are different things. Like for that purpose, we have to send the robots. Like NASA already have sent some rovers on the Mars and moons. Even we are planning to do it. So these rovers are nothing but robots, and they are automated robots. So they will perform different things like digging, then after collection of the soil samples, then making some chemical reactions or chemical equation reactions on it, so to find out how different materials are present in that one. So yeah, that is the process, or you can say that that is the automation process. So these are particular tasks. Okay, these particular tasks are already programmed in that robot. So if I want to say, or if I want to give the idea about automation, I can say that like that. See, automation is the technology by which process or a procedure. Okay, there is a difference. Process is different and procedure is different. It can be performed with the human minimum human assistance. When I say minimum human assistance, because earlier we have to program that robot, we have to design that one, we have to put some sensors at particular locations. So that is the human assistance given to that robot. And once everything is done, that robot can perform that task. Or automation or automatic control is use of various control systems for operating your machineries or processes. This is the similar thing, but it is in a little bit brief. So now, what is the required most requirements for this? So of course, you need a skilled engineer, that is a human, which knows programming or any CAD softwares or designing or like for thinking purpose. So robots right now at present, robots cannot think for themselves, but scientists are working on it, like artificial intelligence and all that. It is the similar thing. So you need a skilled engineer, then you need a CAD. CAD is for designing your parts or robots, robotic arms, or your robotic process. You can design this. Different CAD programs are available for planning the robots. That is a RPA, robotic process automation. Then you need a once the design of the your robot is done, you need a skilled robotic programmer for programming that thing. Then you need, of course, you need some robots, and as those robots perform a particular given task and they cannot think for themselves, we need to standardize each process. Like standardize means, yes, we have to go here, then sense this thing, put it now, like perform some task on it, and again move forward. So these are we have to standardize these processes so that robot can perform those tasks. If it is not standardized, then there will be like nuisance will be there. So they will not perform their task if it is not standardized. But a human can do unstandardized or different processes because they can think for themselves. They can take the decisions. So yeah, you can use the humans for unstandardized process. But when you are talking about robotics and automation, you need to standardize each and every process to perform that task. Now let's see one example. So this is the line of robotics, robotic arm, which are performing a particular set of tasks. Now, so usually what happens? So let's say right now in companies like here we say, see, some are lifting the parts, some are grabbing it, then some are welding it, or some are fixing it on the jig. So for those, only end effector or at the end you can see the grippers, those are different in nature. So this is, you can say, this is a spot welding type. There is one grabbing thing is there. So, and you can see at the base every robot is same. Okay, so because they are working on the same principle, they have to move XYZ, and they have to just give the power to the end effector. So it is doing the same things, but as the end effector or end part or gripper is different, it is performing different tasks. So like I said, if you want to weld, then you can use a welding gripper at the end. Painting, you can use a spray nozzles at the end. So you can use different things to perform different tasks here. Now, yeah. So do you have any questions in this? Like any doubt robotic automation process? So in companies normally they use a single branded robot, like which is only difference in end effector. Because once one robot, if I use a different company or different branded robots, then they will be different in their shape or size, or components will be different. And if anything happens to one robot, I cannot replace with the another one. That's why in company they normally use same robots everywhere. Just end part is different, so that if anything happens to one of them, they can replace it very easily without any major disadvantage. Yes. Okay. So do you have any doubts for this? Hello. Anybody have any doubt or any explanation they want for this?
Sir, actually, we have the question answer session in the last, so that
Okay.
I have muted
Okay.
all the participants right now.
Okay. Okay. So I think
So,
we have
so
done it fast. So I have, let me show you one robotic process automation here. So why the topic is like why China is very great in this thing. So this is for this thing. Now this is everything is automated, so everything is programmed here. So you can see the speed of processing. See, these are also robots, you can say that, because with the help of minimum human intervention, they can perform this task. These are totally fully programmed robots. Here you can see that robot is cutting and welding it. Now for moving also we have jeep cranes or overhead cranes. For screwing nuts, this is also a robotic thing. So now a robot means it is not just a humanoids or a human like things or human like machines. They can be anything which can be moving, which is used to transport from one location to another location, like this car. So this is also called as a robot. Here you can see that robots are performing things like pick and place. This is a manufacturing robot which is used to manufacture sheet metal parts. See that human is only placing some things on that particular thing jig, and robotics performing different assembly here. He is preparing, they're making one mouse, computer mouse. Now here there is one CNC machine is there which is making some coils. CNC is computer numerical controlled machine where you have to use some G codes and M code for performing the particular movement of the machine. As you can see, the speed of the process, it is very fast because it is means robots are working on it. So if humans will do this thing, they will need some time or they will need a very great skill to perform it very accurately. Okay. Yes, that was the process for how manufacturing is done by with the help of robots. Uh, just now, if anybody have any doubts, then they can ask me because I think I'm finished here. This was just a brief introduction about like robotics for automation and what are the requirements. Like from the CAD to the manufacturing, everything is the like you everywhere you need a automation.
The participants who wants to ask the question, please unmute themselves and then they can ask.
Sir, what are the
Yes.
criteria which differentiate between the machines and robot? As
Sorry,
CNC,
can you start it again? I cannot hear you properly.
so what are the criteria which distinguish between the machine and the robot? As CNC is not a machine, but any arm-controlled thing are called robots.
Okay, criteria for machine and robot.
Yes, sir.
Yeah, so see, robot is a slave and machine is also slave. So basically, there is very less or there is no difference between those two words. So now, as we only think that robot is like looking like some humans and all those things, that is called humanoids. If you see, I think Honda company have made a robot called Asimo. It is looking like a human being. So, but now when I say a robot, robot, it can be anything which is used for doing some things, like it is performing some task or robotic or mechanical linkages. If they miss, every robot will not have a power or they will not have a processor, but they can perform different tasks like nut driver. So that is also, if you press it, then it will perform the circular motion and it will pull your press your nut into that particular location. So yeah, basically means to answer your question, there is no difference in machine and a word called robot.
Sir, in few books I read that CNC is not a robot; it's a machine.
Yeah,
So,
so to program CNC, that is computer numerical controlled machine, and
yes,
you have to like some using like CAM softwares, like computer aided machining softwares. You have to generate the CAM programs. They will consist of G codes and M codes. So on the basis of these G codes and M code, your CNC machine is going to work. So you can say that yeah, it is a robot. So it is designed for doing that particular task. So mainly CNC machines are used for removing or cutting the material with the help of some tools. So yeah, those are the you can say that these are also called robots because they are performing some task which is which can be done by humans. But if I sit and if I start to cut the material or metal, it is very difficult to cut it by hand or with the help of some tools. Also, it is very difficult because again I need to get it very accurately, precise one. Let's say in tolerances of microns. So that machine or that CNC machine can do it very easily with the help of that programming. So I think CNC machines are also robots, but they are not
okay,
moving from one location to another location. That's why some people say that those are machines and not robots.
okay, sir. Thank you,
Yeah,
sir.
yeah. Yes, anyone else?
I think nobody is there. Sir, I have one question.
Okay,
Uh, yeah, basically, I'm from the mechanical background and I'm a faculty in
okay.
this department.
My background
So,
is also
if
mechanical.
yeah, so if I want to means start, so from where I can get that basic knowledge or regarding this
Start
programming?
for what?
Yeah, it's like robot programming or whatever the concept you have just shown to us.
Mhm.
So
So
application based
okay,
programming.
okay, I got your question. So see, basically here there are few different fields related to robotics. So first field is you have to design the robot. Okay, that is the one
Okay.
field. For mechanicals, we can work in that field. So for let's say for I think material handling system, I think you have heard about it. So
Yeah.
material handling system is similar to this one. So you have to do some machineries or set up machinery, design it. So that is
Okay.
the one field. Another field is to program that robot. Okay, means making the firmware for operating that robot. And third field is to program the robot to perform that thing. Means so first two things can be done anywhere in the world. Like I can sit here, I can do the robotic mechanical linkages design. Even one any programmer can write the firmware for the robot, but the person who is working in that factory, he have to make a program for doing the things like or we have to go there and we have to sit and we have to program that robot. So that is another field. So if you want to start working in like this, so these three are major fields. So first of all, we have to decide like we want to design a robot, we want to design a firmware for robot, or we want to like make a programming for performing the task.
Okay. Yeah.
Okay, like I said, suppose. Take an example of let's say I'm in 3D printing industry. So take an example of 3D printer. So 3D printer is a machine or it's a robot only. So first of all, I have to design it. Then after designing uh, only mechanical linkages, I have to assemble them. Then I have to write the firmware. Firmware means a thing which can be understood by that mechanical linkages or motors or actuators in our case. So yeah, so now these are two different things like mechanical design and this firmware design. Oh, and once it is done, then that particular 3D printer is ready for work, ready to do some work. But that some work has to be assigned for this, and that can be done by programming for different parts.
Okay.
Okay.
Okay. I will keep.
So yeah,
Yes.
these are three
Definitely.
major fields. So first of all, we have to decide in which field we want to go. So once we decide it, we can start it.
Okay, sir. I will keep that in mind.
Yeah.
Thank you, sir. Yeah.
Yes. Anybody
Anybody,
else?
anybody else want to ask question? Please ask.
Yes. Anyone? Okay. I
Sir,
think.
your
Yes.
anybody want to ask question?
Yes.
Um,
Okay.
okay, sir. I think
Yeah.
it's quite elaborative session that we have. So
Yeah. So
most
basically,
probably,
I want to
yeah.
I wanted to deliver that robotics is means we are surrounded by robots, but our tendency is like looking robot word like a humanoid thing. So that's why I showed you that two pictures. So they looks like a humans.
Yeah.
That's why we correlate them with the robot. But robot can be anything which is performing any task.
Oh, yes, sir.
Okay.
Sir, if you have a time, then you can play the video of the completion that you
Competition.
forward. Yes, sir.
I just okay. Just a minute.
I think, sir, we have a time, sir. Then,
Yeah. Okay. I will play that video.
We have also next
So
speaker.
okay. So just a minute. I want to share. Okay, so this is also present on YouTube. If you see search forward FTC Horcruxes, then you will get this. So Horcruxes is the name of my team. So these reddish t-shirts are from my team. Okay, so you can see here. So this is the whole task. These are my students.
So what is the actual task here, sir?
So here the task was like we have a 2.5 minutes. So in the first 30 seconds, that robot has to do work autonomously. So once we start it, it has to perform that task. And once that 30 seconds goes, it has to work like by remote control, wireless remote control. So in that thing, here is a bridge. So there is a blue bridge and here is a red bridge, and these are platforms. So and these are yellow blocks. These are called stones. So first thing we have to go. We will start from the corner. Then we have to come and we have to bring this platform into this blue triangle. You can see at the right of my screen, and then again come back and grab these yellow stones and place them here. So and again grab it and place it one above another. So the one which is having higher that higher the tower, it wins. So yeah, we won this competition in I think uh, 30th of January 2020. So see here, now they are working autonomously. So all of the robots are stable. So only my robot was working in autonomous period, and you can see the time here. So once the 30-second went, now everything will be manually. That means by using remotes, wireless remote controls. This is the biggest robotic competition in the world, FTC, First Tech Challenge. And now you can see it is placing the blocks. Mine is the blue one there. Yeah, that's the one. 3101. Even we got one more award for this, like Engineering Marvel Award for this robot. It was very, as compared to other robot, you can see the size is very less, but it is performing all the tasks.
Sir, can you tell about the hardware part, like which controller or
Yeah, so
as
for this competition, it is necessary, or we have the controller should be purchased from the FTC only. So for this, we used Rave Robotics controller, REV, Rave Robotics controller.
oh,
I will show you it in one of the picture. It is there, so you can see it is lifting the blocks and dropping it at the top. Now it grabs the block, it will come back.
for grabbing you use a vacuum suction?
No, that arm which I showed you in my PPT, I will again show you.
Yes, sir. I remember.
Yeah, once this is finished, I will show you. So in this competition, as compared to all the other robots, our robot was the smallest one.
Okay.
Basically, it had two arms, the left and right one. And now that is finished, and it is parked at the parking location. Okay, so that was the thing. So that's the here. Okay, so can you see the PPT window?
Yes, sir.
Yeah, so here the control is there. This is designed by Rave Robotics, REV. So it was mandatory to use their controller only. And there is one smartphone also inside here in this particular chamber. So it worked on means for use the controller from the mic that smartphone is utilized for performing this task. These are the motors. This is spool. This is a telescopic arm. So here, if you see it very carefully, you can see a small string is there. Can you see it? So that string is a Kevlar string. So it was used to means that with the help of that much thin string, you can lift up to 50 pounds of weight. That means 25 kg of weight. You can like lift it without breaking. And for lifting the block, we have designed this particular arm. These are silicon pads. So once the block touches here, there is a sensor provided at the back side here. At the bottom, you can see it is here on this plate, red plate, just below this plate. So once that block is touched here, that arm goes down, and with the help of positive compression action, it grabs the part. And with the help of this spool, we can wind the string on it, and because of the winding motion, this arms goes up or down.
Okay.
Okay, this is
Yes,
totally this red and black, whatever you see apart from the electronics, everything is 3D printed, and these are mechanical linkages, like these are aluminum extrusions used for as a chassis.
okay.
Okay,
Yes.
yeah.
Thank you, sir.
Anybody from participants?
Okay, anybody
Want to
else?
ask question?
Yeah, okay.
Thank you, Akshay sir. Thank you for sharing your perspective and knowledge about the robotics for automation. So, on the behalf of Siagat Institutes, NBN Siagat School of Engineering, we are thankful to you. So,
Okay.
I
The
declare.
pleasure is mine.
Okay. So we next speaker is Mr. Tanay Sharma. He will join.
Yeah.
Participant.
Tanmay Sharma sir is already.
So I will introduce him first of all. Then he will start after that his session after that. Okay. So today second speaker we have a second speaker Mr. Tanmay Sharma. He is going to deliver his talk on IoT for automation and AR and VR for automation. So I will briefly introduce him. He is graduated as a instrumentation engineer from Amrita School of Engineering. He has experience of 2 years in the field of industrial automation. He began his career as an application engineer and worked on many projects serving different industry portfolio. He is also trainer in application department and he is training students, professor and customers on the automation products and programming software. He has experience of training about 200 plus participants. Then he moved to business development department under the banner of education network. In this role, he started interacting with various different colleges, professors and students around the India in order to spread awareness about industrial automation. He is working with 40 plus colleges to help them to learn the latest technology persisting in the field of automation industry by providing them training and helping students to get hands-on experience by supporting them in this in projects. So this is all about Mr. Tanmay Sharma. Over to you, Tanmay Sharma. You can start your session now.
Thank you, sir, for such a good introduction. And first of all, thank you for providing me an opportunity and this platform to showcase and make things little bit more in favor of colleges, where they can directly access the technology and they can learn more about it, because at the end of the day the entire industry depends on engineers and indirectly to colleges. So we are happy to be a part of this. So let me start with the presentation. Yeah, I hope everyone can see the screen and can hear me. If someone can confirm.
Yes,
Yes,
sir.
sir.
Definitely, it is.
Thank you. Thank you. Okay. So I'll be talking about two topics. First of all, industrial automation, and moreover, I'll be touching the IoT part of it, that is industrial IoT, what is persisting in automation field right now, and how things are changing from industry 3.0 to industry 4.0. And parallelly, I'll also touch in that same process, I'll also touch the topic of AR and VR in automation. So, starting with the basic layout of the factories. Basic layout of factory involves a building in which there are different, a building which is called a site, which involves different processes. And inside different processes, we have different lines. And in those lines, we have some machines. So we have four component of a factory, that is the entire site, and then subdivided into processes, then lines, and inside lines we have machine. Now, every manager who's handling a factory always wants to increase the productivity of the entire site. With that, want to improve the quality of the site, that is the quality of products, quality of even the consumption of resources. We need to improve the quality of that. And then third, every manager wants to decrease the maintenance time of the site, because maintenance time at the end of the day results into the loss of the particular production. So in order to achieve all these things, what are the available technologies present in the market right now which can be used directly to achieve these three targets? Now, because I have 1 hour, I might not be able to go in too much of depth of things, but I'll request all the participants to, write down those things which they are coming across for the first time, and then later, you can search about them more, and you can get in touch with me. I'll share my contact details at the end. So I'll be covering approximately 8 technologies which are persisting in the market. So as from previous 3-4 days, we are going through a lot of talks about industry 4.0, IoT, and all those things. So I'm not going to spend more time in this, but just to get an overview that how the things changed from the 18th century, and now to today we are in a age where automizing the machine is not enough to meet the competitiveness of the market. We need more out of a machine. We need a machine which can talk to us and can tell us the data, that can talk about machine's health, that whether the machine is working in good environment or not, is the machine productivity high or not. So we need a more smart machine. Automation was there in 2000, around 2000. Automation was done at that particular time. But in today's environment, we need more of internal data of machine to improve the productivity. So to do so, there are plenty of options available in the market, plenty of technologies coming across, but I'll be talking about all the industry, all the technologies provided by B&R Industrial Automation to achieve the desired result out of a factory or a process or a line or a machine. So moving to the first topic, that is scalability. Now, in today's environment, we have plenty of machines in the market which are running. But what if the customer demands changes? For example, in recent time, we have seen a big jump because of the corona. Now, let's take an example. There is a machine which is producing deodorants or perfumes. Okay. Now, these are the liquid which contain alcohol in them. That means the machine is capable to produce a mixture which have alcoholic content in that. Now, because of this COVID-19, the demand of these things will obviously decrease right now. But can those machines be used to produce sanitizers? Instead of shutting down the industry and going into loss, can a machine produce some sanitizer and even make profit in during these times? Now that is called as a smart machine. Now to build a smart machine, the machine need to be scalable. Okay, so depending on the variety of consumer products required in the market, special end customer request, regional requirements, growing range of options in the market, we need to make machines which can incorporate all these demands. Because today, if I buy a machine to do a task A, and tomorrow I need to do task B with the same machine, I should not invest in a new machine. My machine should be scalable enough to do the same task. Now, uh, let's say if we have a standard machine which cost approximately 100 rupees. Now, there is a requirement in the market that, okay, I need to make sanitizer with the same machine. I should not buy a new machine which cost me again 100 bucks. Can I do a 10 rupees of investment in the same machine and can achieve my target? So that is the entire concept of scalability. So in BNR, all the machines built by BNR and all the technologies provided by BNR are scalable enough to incorporate all the new demands of the market. And we can capture all of them with the same existing machine just by investing a little bit more. So that was the thing about scalability. Now, talking about digital twin. Now, in today's environment, there is a lot of augmented reality and virtual reality things are going on. In the same process, can we have a system where we can develop, test, and execute a machine in a virtual format? Now, the advantages of doing so are plenty. For example, let's take now talking about the shorter just a second. Yeah, just talking about digital twin. So to achieve a shorter TTM, that is time to market, better ROI, that is the return on investment, then higher OE, that is the overall equipment efficiency, effectiveness of the machine, and then easy maintenance or easy service of the machine. To achieve all these things, can we develop a machine in the software, test it in the software, execute the program in the software, and then come up with a solution with all the R&D and then make the final version of the machine. Now, all the R&D we need to do a machine, because while building a new machine, we need to have we have idea of what we want to achieve, but we don't have the idea that what changes in the machine can improve my productivity. For example, if I'm taking a 500 watt motor in the machine, what if I take a 600 watt motor? What if I take a 400 watt motor? How my productivity is going to affect with all these things. So all the R&D, testing of the program which goes inside the machine, everything can be done by using digital twin. So that is visualization early in the design phase, optimal sizing and layout, software and function testing. All these things can be taken care by digital twin. Now, to do so, what are the parameters we need to take care of? For example, if I'm talking about the visualization, I am talking about animation, flow of material, collision of the material inside the machine. These all can be taken care by visualization part of the machine. Now, talking about the optimal size and layout, that is the mechanical part of the machine. We can take care of the kinematics, physical dynamics and force, torque, speed, acceleration, deceleration, and all those things. Okay. Now, third component of a machine comes, the most important one is software and the functional testing. Even that can be done by digital twin. Now, how it is done is by using these software. So there are different software. For example, for process simulation, you can use industrial physics. Then there is WinMod and plenty of software like that. Then there is machine simulation, which is MapleSim and MATLAB, which is extensively used in the education and industry also. And then comes the third part, that is the hardware simulation, which is very crucial one. And there are very few options available in the market to make a hardware simulation. Because programming and all those things can be done on simulation, but simulation of hardware is a challenge right now. So in that we have a option called as Automation Studio, which is a one option for all the I can say all the activities for automation. So this Automation Studio is developed by BNR and can be used very efficiently to achieve digital twin. Now, let's take a use case and let's talk about a pharmaceutical industry machine. Now, in a pharmaceutical industry, we have tablets which need to be first of all manufactured, then we need to check whether the any tablet is damaged or not. After checking that, we need to eject those tablets out of the stock which are damaged or which are not fit for use. After that, we need to fill those small tablets in the leaf. Leaf is the plate in which these tablets come to us in the market. Once doing that, we need to put a seal over them and we need to make it airtight. So to develop a machine like this, we need to do a lot of R&D, we have to buy many products to do all those R&D. Now, instead of doing that, if I am able to simulate this machine in digital twin, I'll be able to achieve something like this. So that you can see the real machine and the virtual machine in the same screen. So, yeah, I'll just play the video again if anyone have missed it. Now, just imagine the complexity of this machine and just imagine the time, money required for the R&D of this machine. If I'm physically doing it, I have to buy many components which are costly. I have to invest a lot of time of engineers for programming and changes in programming. Now, instead of doing that, if I can do it virtually, first of all, I have to invest 0 rupees in buying the hardware. Initially, once my design is final in the virtual machine, then I'm pretty much sure that, okay, I need to buy this component. So that is the use of digital twin. Now, another example of digital twin is if I have to make a packaging plant. So I developed this machine in digital twin and I can check the functionality of the machine without even having the actual machine. So you can see a person who is actually standing in the middle of this particular line of packaging, where you can touch and feel the products also. You can do any type of editing in that and then check how your code is going to take that particular change in the situation. Yeah, so that is moreover developed by digital twin. So that is the idea behind it. Now, moving ahead, the third option present in the market is the web-based HMI and diagnostics. Now, we have in India, we have plants which are very big. You can say there might be, let's talk about a wafer packet which comes in our market. First of all, we have to slice the potato. We have to wash it, then slice it, then, bake it. After baking, we need to measure the quantity and then feed it into the packets and then pack it. So there will be plenty of machines involved in this process, in this entire process. Now, that is fine. We are able to achieve our target at the end of the day. But what if I need to make the most out of my plant? So what if I install a small device which is called as the gate manager? Now, gate manager is a space available in the cloud where all the data from this machine is being captured and stored. Now, the advantage of doing so is, let's say if I have 10 factories across the world spread in different geographical area, and I have to check that which factory is working at what efficiency, how much is the downtime of the machine, what production they are doing per day, how many hours in a day the machine is running. To check all this data and to analyze this data and come up with a with the cream of the milk, I can use this technology. So the only change I have to do in the entire existing plant is to install a site manager. If you can see, here you can see the site manager. Now this device captures all the data from the factory and pushes this data to the gate manager. Now through gate manager, any person, any engineer or manager of the factory or the operator of the factory can check the data in single screen. You don't have to wander around different machine, or you don't have to call the other factory to check whether the machine is running or not. In single screen you can achieve all this data. So that is about the remote access connectivity. the advantage of this, as we already talked, that it improves the maintenance effectiveness dramatically. It reduces the training efforts and maintenance cost. For example, if a person, a operator of the machine resigns from the company, and there is no one to operate the machine, even any operator sitting in different similar kind of industry using the similar machine can access these machines online. And if there is a downtime, for example, if the machine is broke down, there is some problem with the program, let's say, then you don't have to wait for the engineer to come from the company to the site and then connect the laptop and try to debug it. The engineer sitting somewhere else can directly connect to the industry and can directly access the data of the machine and can tell that, okay boss, this is the problem and this is the solution for that. So it reduces the downtime of the machine. So it is all about how we communicate through phone calls. Machine communicate by using the site managers. Okay, moving ahead, we have another concept called as open connectivity. Now we understood that how important it is to push data to the cloud and how useful it can be for the machines and factories and for the business. Now, but what is the communication protocol which is being used in doing so? Let's say a machine tells that, okay, out of 24 hours, I am being running for 20 hours and 4 hours was my downtime. Now this data is available inside the machine, but how do we take out that data and push it to the cloud? Now, the solution to that is OPC UA. Now, in the same way, like explaining the same thing again, we have some machines at the shop floor. We have some sensors and actuators at the shop floor. We have some robots at the shop floor. We have some machines, again, different type of machines. Now, the data of all these things have to be pushed to cloud by using something called as OPC UA. That is the time sensitive networking, TSN, OPC UA over TSN. Now, you all might have heard about this particular type of communication protocol, but for those who don't know, I'll just give you a brief introduction. Do you remember those times when we used to have Nokia mobiles with the thick pin chargers, and Samsung used to have the broad pin charger? Then one day, all of these people sat down and they talked about that, no, we need to have a common charging technology for the mobile phones. Okay, over there they made the type B chargers the standard one. Now we are moving to type C, that is another thing, but for all the companies it was made standard by the government. Okay, in the same way, let's say if you have machine with a controller of company A, you have machine B with controller of company B. Every company, if they have their own communication protocol, it becomes very hard to read the data. So in order to remove this particular difficulty, the entire automation industry sat together and came up with a solution that is called as OPC UA, which is an open platform communication protocol. And everyone agreed to this term that doesn't matter which PLC you are using in a machine, every PLC should have this communication protocol in order to connect between two machines very easily. So moreover, this particular OPC UA is a open international, it fits in the open international standard of communication protocol. It collects all the information, not the data. It collects the data in form of information. Okay, this reduces the memory consumption of the data. For example, if there's a very huge amount of data, let's say 0.5 GB of data available with the machine. Now OPC UA will take out the information, not the data. So that will reduce the memory consumption of your cloud. Now the third is end customer demand. It fits in the end customer demand. It can be, because it is a open platform, you can do some changes with the source code, and you can twist it in a format which is more reliable, which is more useful for the end customers. And it is a plug and produce, that is any device from the industry, you talk about motors, drives, HMI, PLC, sensors, any device present in the automation industry can be just plugged with this OPC UA communication protocol, and the data can be extracted. And then there is a large ecosystem in 2018, because after 2018, every company is producing products which need to have OPC UA communication protocol. Yeah. So that was about open connectivity. It provides us the open connectivity so that if you have 10 machines from 10 different machine builders using 10 different controllers, the data can be collected very easily and can be pushed to the cloud. Now, talking about IIoT for brownfield and greenfield. So first of all, let me introduce to this terminologies called as brownfield and greenfield. If a factory is still in the age of industry 3.0 or below it, it is called as a brownfield industry. That means the machines might not be automized, machines might be very, very old. And in India, we face this problem a lot, because in India, we have like 80% of the 75 to 80% of the industry have old machines. So are these old machines capable enough for IIoT? Yes. Without any change in the existing solution what they are having in their shop floor, just by connecting some extra hardware, which is called as Orange Box, you can make a old generation machine act as a new generation machine. That means it becomes smart by connecting Orange Box. Now, what does exactly Orange Box does is that all the KPIs, that is the that is all the data of the machine, can be accessed by Orange Box. Doesn't matter how old your controller is or how unautomized your machine is. Other than that, we also don't want to impact our installed base. That means if I have a machine which cost me approximately 4 crore, though it is old, I don't want to replace that machine and throw it in the scrap and have to buy a new machine. The old machine can very well work with Orange Box, as I mentioned earlier. And we need better data transparency. We need to know that if I'm running my machine at 50% efficiency, what is my production? If I run my same machine at 80% efficiency, what is going to be my production? In order to calculate how many losses I am making. And then maybe I can sit down with my engineer team and work out on the changes I need to do in my machine so that I can achieve better results out of it. So that data transparency is also provided by Orange Box. So that is about brownfield and greenfield, that how easily we can convert a brownfield industry into a greenfield industry. And whatever topics I'm covering here, a detailed knowledge and videos are available on our website, which I'll be showing you at the end. You can also go and take a look at whatever topics which excites you. Now, talking about edge architecture. So let me talk about the automation pyramid. At the bottommost level of the automation pyramid, we have basic sensors, okay, which collect some data. Once they collect the data and send it to the PLC, I need to have the data in my hand, and I need to analyze that data, okay, by using some XYZ software. There are plenty of options available for that. Once I have the data in my hand and I have done an analysis on that, I need to do something called as controlling, or maybe controlling the machine. So it is a closed loop, as you can see. I collect the data, I analyze the data. Depending on the analysis, I give some feedback to the machine, that maybe I can increase the speed little bit or decrease it, or there is some damage in the machine. So, I can take the corrective actions. So in order to do so, I need IoT platform. Because data analyzing, no software in the market right now is capable enough to analyze the data offline. We need to have the online database to do that. And that is where the IoT platform comes into the picture. So to do so, now, though we don't have a software which can analyze 100% of the data very efficiently, but we can reduce the amount of consumption of internet for doing so. For example, if let's say I have an edge controller in my machine, maybe I can do control security, internet connectivity, and data aggregation in that. But for data historian, that is the history of data, maybe I want to check the data from last year. That cannot be done by edge controller. for business intelligence, for machine learning, for long-term storage. I cannot do it by a edge controller. Here I need cloud service to do that. But if I implement Orange Box in the same machine, that is a edge controller with a Orange Box, that is called as the embedded edge controller. If I have that, I can take one more step, that is data historian can be done, because Orange Box has a high capacity of data storage. But what if I come with a better solution? That is, if I implement Aprol technology in that. So I have a edge controller with the Orange Box, with the Aprol technology. I can still do more things, and I can reduce the dependency on the cloud platform. So by using different type of technologies and hardware available in the market, we can reduce the IoT we can reduce the cloud dependency of a machine. Because in India, still we are in an age where, it is very hard to get high speed internet connectivity everywhere, because most of the factories are situated in the remote locations. It is very hard to do so. So by using different technologies, we can reduce the dependency on the cloud. Yes. Now talking about where the data is available. Data is everywhere in the factory. That is, from the process data, we have production data, we have machine data, we have quality data, we have a huge amount of data inside our factory. Then we can compare the data also, that if I have two factories with similar machine, my factory A is doing a production of 1 lakh units, my production B facility is doing a production of more than that, then I can analyze that why my factory 1 is doing less production and 2 is doing more production, if everything is same inside the machine. So these data, that is the process data, production data, machine data, and the quality data. And like this, there are plenty of them. That is maintenance data, downtime data, TTR data, that is TTM data, that is time to market data. So there are plenty of data, categories of data available in the factory. That data need to be analyzed very, very, very carefully. That means that is called as the big data analysis in terms of industrial automation. Though big data means something else in the IT industry, but here in the automation industry, big data is analyzing the data which is present on our shop floor. So I need to analyze my data on the volume basis. I need to analyze my data on the variety basis, velocity basis. There are plenty of factors in which I need to analyze my data to come up with some value out of it. In order to do that, there is two parts of data analytics. I think many of you will be interested in this thing, because it is the new hype in the automation industry. That is the big data analysis and the normal data analytics. So for these, you can visit the website for more details, how to do it, and how it can be, what are the softwares required in doing so, where to store the data, how to get the cloud access of from different platform. So for that is another like a huge seminar we can do on that. But just for the overview, this is the entire story about how the data is valuable for the automation industry. Now, moving ahead, we have something called as predictive maintenance. Now, what is predictive maintenance? There can be, okay, let's take an example. I have a factory in which I have one machine which is producing some goods. Now, there can be two type of maintenance. One is predictive maintenance, which is the advanced one, and one is the normal maintenance. Now, how a normal maintenance can be done is again in two ways. My machine is running, suddenly my machine stops. Okay, I go to the machine, I try to analyze the problem, I fix the problem, I start the machine again. That is the most basic type of maintenance we do at our factories. Okay, but the disadvantage in doing so is the time the machine is not working is my what I can say loss in production, loss in money, and loss in manpower. Now, can I be more smart and can do a maintenance on a regular basis? It doesn't matter my machine is running or not, or doesn't matter at what efficiency it is running. Every 2 months, I do the maintenance of my machine. Again, it is a better solution than the previous one, but still sometime a maintenance is not required at the time we are doing a scheduled maintenance. So again, it will result in some losses, maybe less than the previous method, but still there will be some losses. Now, can I predict that when my machine needs a service? It is as same as we have two-wheelers, four-wheelers in our house. Until unless, if let's say if I have an Activa and I'm riding it, until unless it doesn't start making some abnormal sound, I don't take it for the service. That is one way of maintaining it. The another way of maintaining it is maybe I take it on a regular basis, that every 6,000 kilometer I'll take it for a service. Okay, that is the second option. The third option is, depending on the consumption of the vehicle, can I predict that when the next service will be required? In the same way, in the automation industry also, can we predict when the maintenance is required? Yes, it can be done. It can be done by using big data analysis. For example, if my machine, let's say on day 1 the production is 10 units, day 2 the production has gone down to 9 units, day 3 the production have gone down to 8 units. So,
sir, excuse me, sir.
Yes.
Sir, the slide is not moving, sir.
Yes, okay. Yeah, is it visible now?
Yes,
Sir.
sir.
Yes,
Yeah,
sir.
sure. Thank you. Yes. So in order to achieve that, if my productivity of plant is decreasing regularly, I know there is some problem with the machine. But what is the perfect time to do a maintenance so that I reduce the downtime of my machine? Okay. For example, let's say a factory of maybe firecrackers. If the scheduled maintenance comes at the time nearby Diwali, then it is going to be a loss for me, because that is the time when I need to produce maximum. So we can, depending on the analysis of the data, we can schedule the maintenance of machine in such a way that we do the maintenance at that time when the machine requirement is low, when the market demand is low, so that to avoid situations like downtime of machine at the highest required time, that will give me more losses. Okay, so that is the idea behind predictive maintenance. You predict when you want to do the maintenance of the machine. So in order to do that, again we have so this is the automation pyramid. We have components at the bottom level, then we have shop floor where the machines are available, then we have the processes, which is the upper part of the automation plant, then we have the plant at the whole, and then we have the ERP level, that is the enterprise resource planning. So by doing the enterprise resource planning, we can reduce the downtime of the machine, as well as we can have the downtime at that time when the machine is required the least, so as to decrease the losses. So that can be achieved by edge architecture, that is the edge controller available in the market. Now, again, talking about how many types of data we have energy consumption data, we have vibration data of a machine. If my machine, let's say, if my machine starts vibrating more, that means there is some loose mechanical contact in the machine. Then we have data from motion control, that at what speed the motor is running, what is the temperature of the motor, what is the energy consumption in the motor. If my motor is getting heated up very fast, that means there is problem with motor, I need to do a maintenance of that. So by analyzing different category of data, we can come up with different solution for doing so. So moving ahead, just let me check the time. Okay, we have time. So moving ahead, we have something called as mass customization. Let's say we have achieved all the IoT aspects, that is, we have achieved scalability, we have digital twin, we have web-based HMI and all those things. What is mass customization? Mass customization means, let's take an example. Let me explain it by giving an example. Haldiram is a factory where there are different snacks are being produced. Now, the packing machine for these this particular type of industry is same. That means there are, let's say, 10 varieties of product with them. Maybe a normal namkeen, a mixture namkeen, a peanuts namkeen. The packet size and the packing technology for all these products are same. So do I need to have different machine for packing these product depending on the variety? That can be one option, but what if three machines can pack 10 items instead of 10 machines packing 10 items? That is called as machines with mass customization. That means a single machine useful for multiple type of work. So let's see a video in order to understand it better. I'm not very sure that how much whether the audio will be there or not, but still you can relate to it. So I'll just stop it over here to explain you a little bit. So in industry, we are rolling out the concept of conveyor belt. Nowadays, whatever industries which are coming, which are developing recently, are not using the conveyor belt technology. They are moving to a magnetic conveyor belt. That means there will be a belt which will be magnetic. On that, there will be certain shuttles which will be moving, and those shuttles will be carrying the product. So you will be seeing that more in this particular video. Yes. So I hope that you got an idea that what actually the mass customization means. Again, I'll take one small simple example to which you can relate. Let's take an example of bottle manufacturing industry. Now, in bottle manufacturing industry, today, let's say I'm interested in manufacturing metallic bodies. Now, to do so, I need to have a conveyor belt which is metallic in nature, which can grip a hot metal very firmly and does not change the shape of the hot metal, because when the metal is very hot, it and you try to hold it with a gripper, it might change the shape. So for that you want a conveyor belt, let's say. Now after 2 years, let's say I don't want to make metallic bottles, I want to make plastic bottles. In that case, I need to change all my grippers, because what grippers I was using for manufacturing the metallic bottles might not work with the plastic bottles. So you need to change the entire assembly to achieve so. But if you have a magnetic conveyor belt, what you just have to do is you have to remove the shuttles. As you saw in the videos, you can remove the shuttles and you can place the new shuttles in the same conveyor belt. So as to you don't have to invest much on the uh, changeover of the machine. And these type of conveyor belts, the magnetic conveyor belts, are very easy to implement. For example, you can achieve any shape of the conveyor belt by using different joints. So for example, looking at this particular setup of conveyor belt, I can use all these type of joints over here to achieve the same thing. And every individual shuttle is being controlled individually. That is one more advantage of doing so. Because if you have a conveyor belt and let's say on the conveyor belt you have 10 products, you cannot move those 10 products individually. When the conveyor belt moves by 10 millimeter, all the product will move by 10 millimeter. But in this case, all these magnetic shuttles which are attached to the magnetic conveyor belt can be controlled individually. So that is the another advantage of that. So these are some of the technologies persisting in the market which are related to IoT, and that these are solution how you can implement IoT in your automation industry. And one of them, the biggest one, as I said, is digital twin. That is the augmented reality and virtual reality. So that is all I have for you. These are the topics which I wanted all of you to know, so that you can if you want to learn more about any of this particular topic, you at least know that how many technologies are present in the market. And obviously a huge amount of data is available online for all these technologies. And if you don't find any, you can get in touch with me. But before ending my presentation, I would also like to introduce my company and my department. BNR Industrial Automation, the headquarters is in Austria, Europe, and we are present in the market from 1998 in India and 1978 in Austria. So in India, we entered in 1998. We have approximately 30,000 plants and factories installations done till now across the world. We are working with 4,000 machine builders across the world. We are the fourth largest R&D center for ABB globally. And talking about ABB Group of Industries, we were taken over by ABB Group of Industries in 2017, which is one of the Fortune 500 companies. And since April 2019, we are taking care of the business line of ABB in the field of robotics and discrete automation. ABB, as I said, one of the Fortune 500 companies, have a market of 410 billion across the world, and expecting a growth of 3.5 to 4% per annum. And BNR have approximately 200 offices across the globe, out of which, as you can see on the screen, 90 are in Europe, 44 in Asia, and like that. There are plenty of more offices coming up across the globe, so as we make sure that we are always near to our customers. In talking about India, we are since 1998, and we are present in 8 locations. That is Pune, that is the headquarter, Mumbai, Ahmedabad, Delhi, Chennai, Bangalore, and Coimbatore. So these are the places we are available in India. And also we have our warehouse in Chakan, that is also in Pune, other than the head office in Pune. And we have all the particular type of facilities available for our customer. We have a demo room at Pune office or at different offices. We have training facilities. We have supply chain management. We have a big warehouse, as I said, in India. We have a big team of engineers who are working to automate machines by using the product manufactured by BNR. As I said, that we always believe in innovations. BNR comes up with 400 innovation per year. Approximately, you can see the star over there. So approximately we have a target of coming up with 400 innovations per year. And this is being done from last 15 years. I can say. So you can see the latest innovations what we had in the market is digital twin, what we discussed today. One more which was launched in 2019 was the machine vision, which is a separately different topic. And we are working in all the type of industries, that is, you can whatever factories you can think of: automotive, robotics and handling, printing, mobile, packaging, metal, process industry, plastics, textile, consumer goods, and more than these, because these are only the one which I can incorporate in one slide, but we are working in almost all the type of industries. And some of the example where we references what I can give you in different industries are these. You might be knowing some of them. You might be knowing Hindustan Unilever, Kellogg's, Haldiram, Tata Motors, Audi, Mercedes-Benz, Apollo Tyres, P&G, and Coca-Cola, Heineken, plenty of them. And why I am present in front of you today with all this is because of this department called as BNR Education Network. This department is formed in BNR in 2008 as to match the gap between the education society and the industry. And our aim through this particular department is that we bridge the gap between our customers, that is the industry, and the universities, that are the colleges. So we try to bridge the gap between these. And how do we do it is by training the students, and we train the students by faculties. And how we do that is we collaborate with many institutes. We train the professors over there, and in turns the professor trains the student, and then these students are consumed by the industry where our machines and our hardware is being used. So it is so that we can achieve a win-win situation for all the three parties. That is, institutes get well-trained professors on the latest technology, students get the training out of it, and then they get consumed in the industry directly. So that is our vision by having this particular department. Now, what activities we do in this department is we provide a training called as HOTA training, that is hands-on training on automation. That is a specially designed training platform for professors, only for professors in colleges. And it is a free of charge training. We don't charge anything to colleges for doing so. Once we do that, we do some seminars and workshop to get some students on board. And by using the professors which are trained in HOTA training, we train the students. We provide the training materials, we provide the training kits and all those things, so that professors can train the student. And once they do that, we give them the Automation Studio license, that is the software used for automation. We give them the ETA kits, that is the kits for training and R&D purpose. We give them projects, maybe specially designed projects or projects from the market, so that they can do a hands-on experience. And after that, we also provide industrial visit, so as students and professor can get an idea that how exactly a factory look like. And then we provide them assistance for industrial requirement. That is, if any of our customer who wants an engineer at the shop floor, a new recruit, in that case, all these students who are well trained by the professors can be consumed directly over there. And at the end, we again give revision training to the professors, so as this chain keeps on going every year with new batch of students. So that is the entire idea about Education Network, which is a department in BNR Industrial Automation. You can, again, all those who joined in middle of this presentation, I'm Tanmay Sharma. I'm working in the Business Development Department at BNR Industrial Automation. And you can find the contact details in order to get in touch with me for any of the doubts you have or anything you want to discuss for future. So here I rest my presentation and I'm open for questions.
Participants, if you have any questions, please ask.
You can unmute yourself now and you can ask the question.
Hello.
Yes, ask question.
Sir, I have one question. This OPC concept, it will be having both write and read accessibility in your industry?
Yes, it have many of the things other than that also. First of all, it will have read and write both, that you can give a command and you can take a command, as well as it have a 3 level of security in that in case, like for example, if I'm taking out the data from a factory and pushing it to the cloud, there might be a chance that someone can hack into the system and can access the data, which is very crucial. Okay, maybe some competitor or someone else. So even it provides 3 level of security in doing so.
Sir, even this OPC concept, so many proprietary software will be there. Any open software will be there,
OPC,
or
yes, OPC UA is a open platform communication protocol. You can just write a mail to the organization, and you can get the source code, and you can access it and do changes in that communication protocol with the legal rights.
Okay. Okay, sir. Thank you. Thank you very much.
Yes, sir. Welcome.
Anybody else from the participants?
Sir, how can you provide the training to the faculties?
Okay,
Can
so
you
right now, yes, yes, sir. So right now, we are working in 4 regions mainly. We are working in Pune, Mumbai, Ahmedabad, and Bangalore. These are the 4 prime locations where we are getting in touch with colleges. Once the colleges agrees with us and have a small official tie-up, then we organize trainings where we call different professors from different colleges. For example, we have done 4 HOTA trainings till now. If I can give you some references, then in Pune we have Marathwada College, D.Y. Patil Akrudi, D.Y. Patil Pimpri Chinchwad. We have Indira College. In Mumbai we have Terna College, RIT College. In Pune we have also have SIT, both Lonavala and NBN working with us. Then we in Ahmedabad we have Ahmedabad University. In Bangalore we have again plenty of colleges. So we go in these regions and we organize trainings within the college, and we call other professors to do so. So if any one of you are interested in taking part, who are in these 4 regions, can directly contact me, so that we can take it ahead. And as I said, it is free of charge, because Education Network Department of BNR is not for the profit, is not working for the profit. It is working for it is working for achieving a target which is win-win for all the 3. So we are not looking it from a profit wise. So it is free of charge.
okay.
And
So
the
what
training
about
which
the
we
other
provide
states?
is,
What about the other states? As I am from Uttar Pradesh,
yes. So in
so
other states, what we are doing right now is that, though we are not going there directly right now, next year we'll be there once we get more engineers after this COVID-19. But meanwhile, if any college is interested, even other than these 4 regions, can get in touch with us and we can arrange something. Because as I said that we have 8 offices across India. If not me, then someone else can come and give the training in that order, the nearest office to your location.
okay, sir.
That can
Thank
be
you.
managed.
Thank you, sir.
Yes, thank you, welcome. But it depends on the requirement. In that case, you have to come up for the requirement.
Sure.
Sir,
Yes,
good evening, sir.
yes, sir. Good evening.
Sir, Madhav Reddy, sir, from Hyderabad.
Yes, yes, sir.
Sir, suppose if you do any PG or PhD scholars, you can guide, actually a professor of mechanical engineering department, sir.
Okay.
Suppose, sir, what type of facilities are available, sir, in your centers? What are the
Okay.
centers where you
Yes, sir. Very good
are doing
question. So
project?
we Yes, sir. We support all the professors from mechanical, instrumentation, mechatronics, electrical, ENTC branches to come up with a PhD statement for us. Come up with the idea. We'll provide whatever is required, whatever can be required from our side. For example, we have huge product range of BNR PLCs, drives, motors, HMI, sensors, actuators, and all these things. We are in the market with all these products. So all these products required for the thesis or required for the R&D purpose can be provided, and I can say in past approximately 25 plus teachers have done a PhD thesis by using BNR technology and hardware. So we are open for that.
Okay, sir. Thank you, sir. Excellent, sir. That's
Welcome, sir.
regarding mechatronics, anything related, sir, we will contact you, sir. We have mechatronics branch.
Sure, sir. Mechatronics, I can say one of the use case, if I can tell you, in Mumbai there is Terna College where we have done a FDP for the entire what you can say department, and then now there are plenty of people working with us on our projects and so and so forth. So maybe you can get in touch with the respective person to get a broader respect, or you can get in touch with me after the seminar.
Thank you, sir. Thank you so much.
Yes, well.
Sir, good afternoon, sir.
Good afternoon.
Sir, this is Mr. Anil Kumar from Vignan's Foundation of Science, Technology and Research.
Yes, sir.
Yeah, actually, from this year onwards, we are starting a bachelor degree in robotics and automation engineering.
Okay.
So, in this regard, we want to design some course curriculum with respect to as industrial compliance. What actually the industries require at the end of the graduation, what they expect from the students. Will you help in designing course curriculum?
Very perfect, sir. We actually don't have to do much in that because we already have a curriculum running in plenty of colleges designed by us. You can get in touch with me. I'll share you all the details. And the
Yeah,
curriculum
I
is
have
already
taken
designed
the
and
screenshot.
yes, sir. Sure.
This,
So
this mail is yours, sir. I will contact you, sir.
sure, sir. No problem. We already have curriculum running in many autonomous colleges and private colleges across India.
Across India. Okay. And
Yes.
oh, you are a member of the ABB group also.
Yes, sir. We in 2017 we became a part of ABB Group, and from 2019 we are taking care of the business in robotics and industrial automation. We are taking care of that part of the business of ABB because ABB is having many lines. They have power and they have grid portfolio. They have plenty of portfolios, out of which one portfolio is robotics and automation, which is taken care by BNR.
Okay.
So
Uh,
even
uh,
if you want to get in touch with the robotics part of ABB, we can direct.
no, I am already in touch with them, and the president of ABB Robotics is our viewers member also. Hello. Hello. Hello.
Yes, sir. You
Is
are
my voice
audible.
audible, sir?
Yes,
Yeah,
go
yeah.
on. Continue.
Sir, I will contact you people, sir. Guarantee.
Okay. I think Tanmay Sharma sir has
Uh,
not available.
Facing some problem, network problem.
Yeah, yeah.
Yeah.
No issues, sir. We will provide the contact
Uh,
details of the speakers. No issues. And
okay.
for the
Okay.
sake of right now, I think you must have taken the snapshots. Yeah.
And one more thing, sir, I am congratulating the organizers also for this wonderful program on mechatronics and automation, which is one of the core and
Sorry,
the upcoming period.
sorry, sir. I lost the connectivity in middle because there was a power cut.
No
Repeat
issues.
your statement.
No problem, sir. That's what I will contact you, sir. I have got your mail ID and phone number. I will contact you within one day. So,
Sure,
what is
sir.
the
No
right time to
problem.
call you, sir?
Anytime, anytime. This is my full-time work, so you can get in touch with me anytime. I'm heading this department,
Okay.
education network, so that is my priority work. Yes.
So, most probably, I will call you today night only, sir.
Sure, sir. No problem. Thank you.
Thank you. Thank you.
Yes.
Anybody else from participant? Any questions? Any questions, please? Yes. Anybody want to ask question?
Okay. I think that is, yeah. So you can proceed with the vote of thanks.
Okay. So Very much thank you for Tanay Sharma to being with us. So he has shared very useful knowledge. So the initiative that B&R Automation has taken to go in hands with the colleges, and they are providing training to the student as well as say professors. So that is very good thing, and that will be helpful to both the industry as well as student and professors also. So I wish that in the future our institute will planning to have a one training program for student as well as faculties also. So I will be very much thankful to him. So having such program at our institute. So thank you very much once again, sir.
Sure, sir. You are most welcome to get in touch with us, and we can start a full-fledged program with you. That will be
Yes,
very,
yes.
very helpful for us also, and for students also, I
De-
can say.
Okay.
Definitely, sir. We will be in touch. And with your permission, I will share the same PPT of same screenshot with all the participants. Because as of right
Sure,
now,
sir.
we have some limited participants who have joined us, but registered participants count is much more. So we will share with them.
Yes, sir. Sure.
Yeah, yeah,
Yes, sir. That
definitely.
will be great help.
Thank you, sir.
Thank you, sir. Thank you very
Okay.
much.
Thank you.
Great.
Thank
Thank you all the participants. And so we will join tomorrow 11 a.m. with our next speaker, and that will be the last day of our FTP. Sainam Jadhav sir, should I close
Yes.
now?
Yes. Close the meeting. All the participants we are closing now.
Yeah. Okay. Thank you all. We'll meet tomorrow at 11 a.m.